Initializing ADDS and Entra Connect Lab. Configuring domain trust plan. Trust relationships established between root, tree, and child domains.
Scaling the lab to global proportions. Every site now running Active Directory domain services. Thank you for watching, Vince.
Welcome to the Active Directory Domain Services and Entra Connect Lab. ADDS is the well-known abbreviation for Active Directory Domain Services. I'll use that abbreviation to refer to that role for the rest of this video. During my studies for the AZ800, I developed a solid lab environment for ADDS. I used this environment to test the concepts from the curriculum. The purpose of this Hyper-V lab environment is to build a complex, multi-domain Active Directory infrastructure. This lab consists of two forests connected together by a two-way forest trust. Each forest has its own ADDS schema. One of the forests contains a root domain, a tree domain, and a child domain. The root, tree, and child domains all share an ADDS schema. This is an important point in the curriculum, and this lab helps to illustrate that concept. Once the ADDS environment is built, we will configure a server to synchronize our ADDS user pool to Entra ID with a technology known as Entra Connect. Microsoft Entra ID is Microsoft's cloud service that manages user identities and lets users securely sign into applications and resources like the Office suite, for example, Outlook, SharePoint, Word, Excel. Microsoft Entra ID is formerly known as Azure Active Directory. Also, this lab environment is an excellent setup to test how Server Manager and Windows Admin Center behave. We will be able to see how they are used to manage servers. On my GitHub site, where the link is in the description, I have 8 scripts and some supporting files that make up this lab. It's called the ADDS GPO Entra Connect Linux AD Join Lab. I've made some visualization diagrams to help explain this lab. The diagrams are on my GitHub site, and they're also embedded into the README file. That's what we're looking at right here. I'll give a high-level overview of the entire lab setup with the help of these diagrams. I'll refer back to these diagrams throughout the video. After looking at the diagrams, we'll take a look at the code and how to configure the ADDS environment and how to get it synced with Entra ID. At the very end, we'll join a Linux machine to the domain and take a look at how Kerberos tickets are issued and used. This first diagram is the trust plan. We will begin the lab by setting up the minecraftmoose.com root domain and joining some servers to that domain. Next, we will build the WAC tree domain off of the root domain. This creates a tree root trust. Next, we'll build the dev.moosewyre.fun child domain off of the tree domain. This creates a parent-child trust. Finally, we'll create a second forest, which is megamooselabsfun.com. This makes megamooselabsfun.com its own root domain. Then we build a two-way forest trust between the two root domains. Some of the features of the lab are how to create and promote domain controllers, the complex Active Directory infrastructure, the root tree child in a separate forest. There's some conditional DNS forwarders and some automated scripts that help build user pools. So you need Windows 11. I've used a custom function to build my virtual machines. You can use PowerShell or Hyper-V Manager. I'm using a generalized image of Windows Server. I'm using 16 gigabytes of RAM, but 32 gigabytes would be ideal. And you'll need a Hyper-V Windows Server acting as a router. You'll also need your own Azure tenant and the ownership of the domains you plan to sync to Entra ID. So we'll create 4 different domains in on-premise using Active Directory Domain Services. We'll sync all of that to Entra ID, but we need the ownership of those domains. How to use these scripts is to follow the comments and the examples included in each one. This is a brief overview of the lab architecture. So minecraftmoose.com will be, its domain controller will be anc-dco1, IP address 192.168.77.7, root domain controller. Then we'll create moosewire.fun, which will be a tree domain. Its domain controller will be gnome-dc01, IP address 192.168.88.8, tree domain controller. This is a key concept from the curriculum. We have a name change, but we share a schema. So that's different than a two-way forest trust. Next is dev.moosewyre.fun, which is a child domain. Its domain controller will be er-dc01, IP address 192.168.100.9, child domain controller. Then finally, megamooselabsfun.com, jun-dc01 for its domain controller, IP address 192.168.99.9, forest root domain controller. This diagram represents our Hyper-V router. The main prerequisite for this lab is a Hyper-V Windows server acting as a router and a DHCP server. I've made a laboratory prerequisites lab that includes the process on how to set up a Hyper-V Windows server as a router. The code for this is on my GitHub site, where the link is in the description, and I've also made a how-to companion video that is on my YouTube channel that can assist with the setup. This video will not cover how to configure the lab router, but as I mentioned before, the links to the helper video and the code to create the Hyper-V router are in the description. So looking at the diagram, at the center of the diagram is our Hyper-V Windows server acting as a router and a DHCP server. So the LAN of my home network represents the pathway to the internet. That's this Wi-Fi 192.168.1.0/24. There are 5 LANs and then 1 pathway to the internet. All 5 of these LANs can access the internet. All LANs have network connectivity with each other. This creates a mesh topology. The Linux LAN will represent the network where the Entra Connect server will be. This is a key concept for the exam. All forests must have connectivity to the Entra Connect server. Each remaining LAN represents an ADDS domain, an Active Directory Domain Services domain. This allows us to quickly program in the network information by utilizing DHCP and networking. So as we turn servers on to a network, they get an IP address and DNS information from the DHCP server, their default gateway, and then they're able to access the internet, and then also their domain controllers. This next diagram highlights the mesh topology of the network. I've left out the pathway to the internet, and this just shows the mesh topology between the different local area networks. We can see each domain and its servers along with the IP schemes for the local area network. For example, here is minecraftmoose.com. It has 4 servers. There's only 3 here in the diagram, but it has ank-dc01, ank-server01, ank-pow01, and then we'll also have a WAC server, which will be ank-wac01. The moosewire.fun domain will just have one domain controller, and then our dev.moosewyre.fun will have a domain controller and a server. megamooselabsfun.com will be jun-dc01 and jun-svr01. So that will be the 2 servers in that domain. And then we also see their IP address schemes. And they all have connectivity to the Entra Connect server. So we need our forests to be able to have connectivity to the Entra Connect server. So now we will talk about Entra Connect. So this is a diagram of how Entra Connect works, or how connectivity is needed for Entra Connect to work. Excuse me. So we'll get into the photos here. So we can see each LAN, for example, moosewire.fun, has its domain controller gnome-dc01. Its IP address 192.168.88.0/24 has connectivity to the Entra Connect. And that is true for every other Active Directory domain that we see in the diagram. So minecraftmoose.com and megamooselabsfun.com both have connectivity to Entra Connect. The top part of this diagram is a basic representation of how Entra Connect works. So as we can see, we have the minecraftmoose.com domain, and then its tree domain, and its child domain. So this entire forest needs to have connectivity to the Entra Connect server. Then we have another forest, which is megamooselabsfun.com. It needs to have connectivity to the same Entra Connect server. There are some good diagrams we'll look at from Microsoft that show a common misconception is to have one Entra Connect server per root domain or forest, but you need your forest to have connectivity to the same Entra Connect server. The bottom part of this diagram is a basic representation of the forest structure. So on the right, we have megamooselabsfun.com. It is a root domain, and it's the only domain in that forest. And then we have the minecraftmoose.com forest, and it has 3 domain name spaces. It has the root domain, which is minecraftmoose.com, its tree domain, which is moosewire.fun, and then a child domain off of the tree domain, which is dev.moosewyre.fun. The last topic we need to talk about at a high level is password hash sync. During the configuration of Entra Connect, you will need to pick either password hash sync, pass-through authentication, or Active Directory federated services. These are used for sign-in authentication. Password hash synchronization syncs a hashed version of a user's password from an on-premise ADDS environment to Entra ID. Authentication happens in the cloud. This is the simplest and most common method. So our user pool will be here on the Active Directory server. The passwords are not stored on the server. A hashed value of the password is stored on the server. A Entra Connect server is used to sync that hash information to Entra ID. Even though these are the most common methods, you may be stipulated by a contract that your password hashes cannot be stored in the cloud. Another stipulation could be policy, law. For whatever reason, your company is not allowed to store Active Directory domain services hashes in the cloud. That is when you would use pass-through authentication. This does not store passwords in the cloud. When a user signs in, Entra ID forwards the password to a lightweight on-premise agent that validates the password directly against the Active Directory in real time. So that is how you meet that requirement. But in this example, we'll be doing password hash synchronization. Another option is Active Directory Federation Services. This is where authentication is fully handled by your on-premise Active Directory Federated Services server. This has a more complex setup. However, it supports advanced scenarios like smart card authentication, on-premise sign-in policies, and integration with third-party identity providers. So I have this example website of how a hash works to explain the concept. So we'll type in super secret password 123. I should probably make it a capital S. And we'll use the SHA-256 hashing algorithm. A hash value is the result of a one-way mathematical function, the hashing algorithm. That's what these are along the bottom, and we just use the SHA-256 encryption for our hashing. Active Directory Domain Services stores passwords in the form of a hash value representation of the actual user's password. So this is the actual user's password. This is a representation of what Active Directory stores on the server in the database, in the Active Directory Domain Services database. There's no method to revert the result of a one-way hashing function back to the plain text version of the password. So now I'll change the password. I'll just put an exclamation point at the end. I'll copy it real quick. Paste it in there. So now I've changed it. I've added an exclamation point. We run the hashing algorithm. We can see that the hash has changed, but then we go back to our password. We run the hashing algorithm, and it's back to the original value. So the server has the hashing algorithm. You enter your password. It's run through Active Directory Domain Services, that domain controller's hashing algorithm, and then if it matches what's in the database, it lets you onto the server. This is the information that we want synced to Entra ID. That is password hash synchronization, and we'll see that selection when we set up the Entra Connect server. Now that we've taken a high-level overview, excuse me, of the entire lab, we'll begin to take a look at the code. As I mentioned earlier, I have 8 PowerShell scripts with the steps on how to set up the labs. There's also some supporting files included to help with setup. Before we jump into the code, I'm just going to bounce over to the host and show the specs and some of the requirements for the lab. So here we are on my, oh, excuse me, let me get logged in. All right, my Hyper-V host is a Dell laptop. It's an XPS 9520 using Windows 11. Oh, excuse me. And then 16 gigabytes of RAM, two 8 gigabyte sticks. It's a Windows, it's got an Intel Core i7 and 20 logical processors. These are the Hyper-V switches that are needed for the Hyper-V router to operate. So another requirement is to have a Hyper-V Windows server acting as a router. So this, I've set one up using Windows Server 2025. It's using 1 gigabyte of RAM in the desktop experience. So I'll just pop in here and show some of the settings. So we're going to open run network control panel applet.cpl. This will take us directly to the network adapter screen. So the Hyper-V router has one pathway to the internet and then one adapter per local area network. Our 4 Active Directory domain services domains are AnchorageNet, GnomeNet, Eagle River Net, JunoNet, and LinuxNet will represent our Entra Connect local area network, where our Entra Connect server will be. So all the other forests will have connectivity to this network, and then we will sync to Entra ID. I have used a custom function to quickly build my Hyper-V virtual machines. The link to the description of that code is in the description. But before the lab gets going, I have pre-staged all the servers with their installed roles, rename their computer name. And they are all in a saved state. So what this means is I've booted up the operating system. They are in a running state. So rather than shutting them down and booting them up later, I've saved them in their running state, and then we will resume them as we proceed through the steps in the lab. Another thing to note is I used a golden image to create all of these virtual machines. That means all of the virtual machines that you see today will have a custom background image. They will be set to the Alaska Standard Time Zone, and they have 2 accounts that are one administrator, which is Mega Man, and then a standard user account, which is Rush. So each golden image, when you open it up, it has 3 accounts: the default administrator account, a administrator Mega Man account, and then Rush. When we promote these to domain controllers, Megaman and Rush will be created as Active Directory domain services users. So ADDS users, they will be created in the user pool. They will not be given enterprise admin rights. We'll give them the rights, and that's part of the lab. But that is just one thing to note when you see Megaman and Rush here. That's because my golden image was built so that on first boot up, they are included with the operating system. Okay, so we are finally ready to start taking a look at the code, and then we will begin configuring the lab. But I'll go over the key scripts and how to configure. So, excuse me. So in step 1 of the procedure, we create all 10 virtual machines that are needed, and the lab expects you to already have the Hyper-V router. You don't necessarily need to use my custom function, even though it's fun and easy to use. You can just use Hyper-V Manager. You can even just run each one from an ISO, however you want to get, you can use PowerShell, however you want to get the virtual machines created. So the first part of this script represents the state that the lab is in right now. So step 1 is just getting your router, getting all of your virtual machines powered on for the first time, get the administrator password set, rename the computers, and then install any features that are needed. For example, the privileged access workstation, the Anchorage PA. This will be our management server. There's quite a few roles that need to be installed on this server. But all of that has been done ahead of time just to make the lab a little bit more efficient. So this new -lab_VM, this is my custom function that I use to create virtual machines. It's pretty easy to follow. So new lab, the name of the virtual machine is ank-dco1. It's using the Anchorage ank-net Hyper-V switch, and it's going to use a generalized image of Windows Server 2025 core, and it's going to start with 2 gigabytes of RAM. The first thing I want to note is memory management. My host has 16 gigabytes of RAM. To do this lab as it is laid out, you would need at least 32 gigabytes of RAM. I'll be managing my memory to make everything work. One example of memory management that we can leverage for us is to increase the amount of RAM that a virtual machine gets during the initial configuration. So on our domain controllers, I have given them 2 gigabytes of RAM. We will do the promotion, get them all configured, and once there is no more configuration, we'll shut them down, drop them to 1 gigabyte of RAM so that we can start more virtual machines, and then we'll just try to start as many virtual machines as possible. It is possible to run them on 512 megabytes, but the performance varies depending on your goals. So when you look at the creation of the 10 virtual machines, that's what this command represents is, okay, we've stood up this virtual machine. However you wanted to do it, you can do it with Hyper-V Manager, totally fine. So once we are inside the guest operating system, I've renamed the computers and installed the roles like I mentioned earlier. Let's talk about each one. So in this one, I've renamed the minecraftmoose.com domain controller to be ank-dco1. And then we've installed the Active Directory Domain Services role and then restarted it, and then now it's in a safe state waiting for us to go inside and begin the configuration, which is the steps later in the lab. But for now, we'll just move on, create the next virtual machine, which will be a server, and then all we've done is just renamed it, and it's just another server. And we didn't even install any roles on it. We're just going to join it to the domain to demonstrate group policies and different ways to interact with the lab environment. Next, we make a member server called ank-paw01, which is privileged access workstation. This represents our management server. So I've renamed it, and then I've installed all of the management tools. So keep in mind that means this server is not a DNS server. It's not an Active Directory domain controller. I've just installed the management tools, and then we will manage the infrastructure from this server. We'll also take a look at PowerShell remoting and different features and ways to manage the infrastructure, for example, through Server Manager. But it will have these roles included. Also, when you have domains in different subnets, even if they're part of the same forest, you do run into permission issues with WinRM. So in this case, for the lab environment, I have set the trusted host value for the clients to be any IP address. That is what this asterisk represents. In production, you would use a specific IP address depending on your goals, but for a lab environment, we've just used this asterisk to represent any server will be a trusted host. So anytime the server tries to communicate with another server, it's going to trust it. Then we need to restart the service, but then I restart the computer, and then it's in its safe state. Then we'll create our Anchorage Windows Admin Center server. This one will be Windows Server Core, Windows Server 2025 Core, and then that's how we'll stand up our instance of Windows Admin Center. And I did miss one note. Our domain controllers will be using Windows Server Core, which makes them more secure. This means that if you were to remote to them directly, you would have to know all of the commands to manage the server. But then we'll manage it through the GUI through our management server. So this is a big point in the curriculum, is that you try to manage everything from a central location behind one pane of glass, if you can. So that's just a note about all of the domain controllers we'll be using Server Core. So at that point, we'll create our next domain controller, which will be for the moosewyre.fun domain. Its name will be gnome-dc01. It'll have the 2 gigabytes of RAM. We'll do the configuration and then drop it back down, to 1 gigabyte. So I've renamed the computer, installed the ADDS role, and it's in its safe state. Then I've also created the dev.moosewyre.fun domain controller, renamed it, and then it has the ADDS role installed. There will be a member server for the dev.moosewyre.fun.com domain. It's ER-SVR01 for Eagle River Server 01. And then the final domain controller represents our second forest. This is megamooselabsfun.com. Its name is Jun-DC01 for Juno domain controller. Same plan with the 2 gigabytes of memory, dropping it to 1 after configuration. It has the role installed. It will also have a member server called Jun-SVR01. And then the final server is our Entra Connect server. It will be in a different local area network than the other domain controllers. And this is the server we'll use to sync Entra Connect that we will install Entra Connect on and sync to Entra ID. So now the configuration moves on to the first domain controller. On every server, I try to create a firewall rule that allows it to respond to ping. By default, when you stand up a Windows server, it won't respond to ping, so this is nice for testing. Then we'll set the static IP address information. Note that the DHCP server has the domain controller's IP addresses programmed in as DNS addresses for their LANs. So when a machine is joined to the local area network, it will get this IP address as its for its DNS, and that's because that is how I programmed the DHCP server. So it is important to use this specific address. We program it in its default gateway, and then we point DNS resolution pointing to itself. And then we promote the domain controller. And then we build the site objects. This is how we'll manage replication. In PowerShell, we'll use rep admin to look at how the replication works. But then from our privileged access workstation, we'll also use the GUI sites and services to take a look at how the entire lab environment is configured. We'll create a conditional forward. This improves performance in the lab. And then finally, we will take our standard Megaman and Rush accounts. I mentioned this earlier about the golden image. So these accounts during the promotion, they were there before we promoted the domain controller. So now they're domain accounts, Rush and Megaman. We will get the same groups that the enterprise administrator, the default administrator, is a part of. So the default administrator account, for example, is a part of the enterprise admins group. So these are all the groups that the default administrator is in. This little bit of PowerShell code will put Rush and Megaman into all of these groups. And then we'll disable the administrator account in each domain to kind of drive home that we've disabled the administrator account. We're making our network more secure. And then these are now our enterprise admins. Then we will build our default user pool for each domain. We'll do this one at a time through the servers. But now I'm just going to step through the PowerShell code. So within the guest operating system of our Anchorage domain controller, the ank-dc01 for minecraftmoose.com, we'll run this bit of PowerShell code and it will create these users. This is an array of strings. We're going to use a for each loop to iterate through this list of strings. So these are the bosses from the video game Mega Man 1, and they are going to represent our users in Active Directory. So we define some variables before we create the account, and then here with the new -AD user, the new -AD user command, we will create the Active Directory domain services accounts. As we iterate through this array of strings, for example, the name will change. So the name for the first Active Directory account will be Gutsman, the second one will be Cutsman, the third one will be Electman. And so these values will change as we iterate through the object. After the account is created, there's some more properties we can set to the Active Directory domain services accounts. And this is important because all of this information will actually sync to Entra ID. So not only are we syncing the password hashes, but we're also going to be syncing their postal code, what city they work in, their PO box, their job titles, stuff like that. Then we'll create some groups that we'll use for a group policy. So we'll create this group inside the same organizational unit that the users will be placed in. And I did miss a step there. We are going to create a new organizational unit, and then all of the users are going to be placed inside of that new organizational unit. So we create this organizational unit, we run through the PowerShell code, and it creates our user pool. Then we're going to create this group called MCM-RDS users, and we're going to add all of the members of that organizational unit to this group. And then we're going to place that group inside of the organizational unit. And then we'll do this for each domain controller. So it's just a different a different username set for the other domain controller. For example, this is moosewyre.fun. So it's Bubbleman, Airman, Crashman. But then it's the same fundamental code. We will build a organizational unit. We will run the code to build a pool of users. And then we'll create this custom group that will contain all of the users within the organizational unit. And another important point I missed is these will be domain local groups, and then we will test a concept from the curriculum where domain local groups are allowed to have members from anywhere in the forest, but their permission only goes as far as their domain. Whereas global groups have members can only be from its own domain. So you have a global group, it can only have members from that domain, but the permissions can be assigned anywhere in the forest. So that's a key that's a little bit tricky. So these are going to be domain local groups because we're going to have a second forest and different domains, and we want to be able to add users from anywhere in the forest. So we want to take a user from anywhere in the forest and put them in this group. So that's, and we'll go over it during the configuration, but each of these groups will be a domain local group. And then we just repeat the process for the other two domain controllers. Okay, so the next part is we're going to build the group policy objects. So now that we have a domain controller stood up, we're going to, oh, excuse me, that's not till later. So we're going to join we're going to join our machines to the domain. So we're going to take Anchorage Server 01 and WAC 01, and we're going to join it to the minecraftmoose.com domain. We're going to do that with this add computer command. So we'll get them added to the domain. And then our paw is actually going to be in a different subnet than the Anchorage domain. So we'll have to point its DNS to the minecraftmoose.com domain, before we add the computer to the domain. So basically we're just adding our 3 computers to the domain. This one's a little tricky because we have it in a different subnet. So when it got its IP address through DHCP, it was assigned a different DNS address. And then here we're assigning it the one that we want. Then we're going to create an organizational unit, and we're going to move all 3 of our domain join servers into this organizational unit. And the purpose of this is so that we can attach a group policy to it. So at this point, the infrastructure is set up to do a bunch of testing. You can do all of your own group policy testing and start playing around with stuff. I just have 2 quick default group policies. There are 2 main types. There are computer group policy objects and user group policy objects. So there are computer policies and user policies. We'll use a user policy to set a custom wallpaper depending on who the user is. And then we'll use a computer group policy to add a domain local group to the remote desktop group of a local group on a server. So let me say that again. So you have a server and then it has local groups on it, even if it's domain joined. There is a local group called the remote desktop users group. And then this group policy will add a group to that local group on the server. So for the user GPO, I have coded it in such a way we can do it in all with PowerShell. So we'll be able to download the file that we want to be the desktop background, share it out on a file share, build the group policy object with PowerShell, set the settings, and then attach the group policy object to the organizational unit or site, depending on your goals. We'll play around with that during the lab. So here we download the background image, we share out the background image, and then we begin to create the group policy. We set some of the settings like the wallpaper path, its style, and if the user can change it or not, and then we link the group policy object to the organizational unit. And then at that point, we can do GP update on the different servers and begin testing. So the second group policy that we'll do, we'll configure with the graphical user interface from our privileged access workstation. So we're going to right-click on our cross-domain 01 organizational unit inside of the group policy management console. And we're going to click on create a GPO in this domain and link it here. And then we're going to give it a name. And then we're going to go into the security settings to this restricted groups. And then we're going to add our domain local groups to that restricted groups. And then this is the list, the procedure list. So we'll just go through each step, and then we'll create that group policy, and then we'll apply it and begin testing. And then I also have the steps to do the wallpaper with the GUI if you don't feel like using PowerShell. Okay, so now we'll move on to the moosewire.fun domain controller. So on every server in the lab environment, I like to create a firewall rule that allows the server to respond to ping because it will not by default. We set its static IP address and gateway information, and we point its DNS to the minecraftmoose.com, the ank-dco1 minecraftmoose.com domain controller. So once we have DNS set up correctly, we can run the promotion commands. And what you'll notice about the promotion commands is this will be a tree domain. Its parent domain is minecraftmoose.com, and the new domain is moosewire.fun. After the promotion, we'll add a conditional forwarder just for lab performance. And then we will take our standard accounts, Mega Man and Rush, and add them to the same groups as the administrator and disable the administrator account. So this part of the lab usually goes very well, but you want to monitor replication. So at this point, you can run repadmin show repl. You can try to sync the domain controllers and see if you're getting any errors, or you can go in the GUI from our privileged access workstation and you can right click on an object and force the replication. You want to make sure that your replication looks perfect before you promote your child domain controller. So that's what all of these commands are about. One thing I left out is we will take a look at the Active Directory database and its partitions. So after we create the first domain controller, we will go in and we will take a look at the partitions that are created. Then we'll create this tree domain and another partition will be added because they share the same schema. And then what we will notice is they share the same schema. The minecraftmoose.com schema is shared by moosewire.fun and minecraftmoose.com. And these commands are the procedure to use the ntdsutil command to take a look at the partitions. We won't have any servers to join to the moosewire.fun domain in this lab example. We could stand them up, join them, play around with them, but just in terms of time in the video and space on my hard drive, we will not be creating any member servers in the moosewire.fun domain. But you absolutely could. So next we will talk about the third domain controller, which will be the ER-DCO1, and this is for dev.moosewyre.fun. Same thing, I like my firewall rule that allows ping, and then we set the static IP address information in its default gateway, and then we point the DNS to the root domain. So even though the tree domain this is going to be a child domain off of the tree domain, we still point DNS to the root domain. What you'll notice about the promotion that's a little bit different is its domain type is a child domain, and then its new name is dev, and its parent domain name is moosewire.fun. And then we'll do the same rigmarole with the standard user accounts. We will place them in the same groups as the default administrator account and then disable the default administrator account. And then we'll take a look at replication after the promotion, and then we'll see how everything comes online. And then we'll also take a look at that partition and watch how it behaves. And then we'll join our member server to the dev.moosewyre.fun domain. And now we're moving on to our second forest. So this is megamooselabsfun.com. This will be a root domain. It's going to have the same firewall rule to allow ping. And then we'll program in a static IP address and point DNS to itself. And then make it a root domain. So this is the code to promote a domain controller when it's going to be the root domain. And then we'll take our standard accounts, place them in the enterprise admin groups, or excuse me, the same groups as the default administrator, and then we'll disable the default administrator account. And then we will have one member server joined to megamooselabsfun.com. This is just a brief overview of different trust types. And then the last part of this script is setting up the two-way forest trust between minecraftmoose.com and megamooselabsfun.com. So we'll need DNS conditional forwarders in order to do that. There's different ways to do this, but for this lab, I've just used a conditional forwarder. So on the Jun-DC01 domain controller, we'll point this forwarder to minecraftmoose.com and then program in the IP address. And then we'll do the reverse on the Anc-DC01 domain controller. We'll have a conditional forwarder pointed to the megamooselabsfun.com domain programmed in with its IP address. From that point, you can use the GUI to create the trust, but I have the procedure to create the trust with PowerShell. So these pieces right here are known as objects, and then objects can have something called methods. So for example, this is the method running off of this object. So I've coded this in to create the two-way forest trust between minecraftmoose.com and megamooselabsfun.com. And you need to run this from the Jun-DC01 domain controller. You could run it from either one. It's just how I've coded it. The remote forest is going to be the minecraftmoose.com. One of the tests that we'll do, we'll create a domain local group in the root domain minecraftmoose.com, and then we'll add users from another forest to the group. So we'll take users from the megamooselabsfun.com domain, but we'll put them in a minecraftmoose.com group. And then also we'll add that group to the remote desktop users group on different servers, and then test the remote desktop capability. Once we have the entire lab set up, we will stand up our Entra Connect server, which has to be Windows Server Desktop Experience, and then we will sync all of our users to the cloud. So one of the requirements is you have to have your own Azure tenant, which will then have an instance of Entra ID. You also have to have domain ownership of the domains that you plan to use in the lab. So here we are on my Azure tenant, and we're going to go to Entra ID. And first, we'll just take a quick look at the user pool, just to show that I have no users in my user pool. Just me. I'm the only user. So we'll go back into Entra ID. Take a look at the custom domain names. So I have purchased these domain names. So moosewire.fun, minecraftmoose.com. And not only have I purchased them, but I have synced them with my Entra ID. So there is a procedure when you want to add add a custom domain name is I have ownership of moosewire.fun, and then I made the dev.moosewyre.fun domain within my Entra ID, and that's because I own moosewire.fun, and then I can make child domains. So if I wanted, we could make dev2. And then now it has created it. And now we have a new child domain. So we could stand up a new domain controller called dev2, or a new domain, and then have a domain, or excuse me, yes, stand up a new domain called dev2.moosewire.fun, and then sync all of the user pool. So that is a requirement for this lab, is that you have purchased the domain name and then sync them to your Entra ID. There are tons of supporting videos on how to do it. It's super easy. Depending on which web registrar you use, it can be very, very easy. So the final two scripts we're going to cover are just how to join a Linux machine to the domain, and then how to stand up our WAC server. So basically we're going to use a Ubuntu ISO to create a Hyper-V virtual machine running Ubuntu server. One little trick is we have to set the firmware to, we have to disable secure boot in the firmware to get the OS installation wizard to kick off. So then we'll start the virtual machine, and then we will add a DNS record. So we'll get the IP address of the Linux virtual machine, and then we'll add a DNS record in our megamooselabsfun.com domain. So we're going to join this Linux machine to that second forest, the jun-dc01. So we'll just make a DNS record in there. Just to make everything easier, you could just use the IP address, but we're going to make a DNS record. It's part of the curriculum to manage DNS. And then we are going to share out a file that we'll use to test permissions in the Linux joined machine. We'll install all the dependencies that we need. It's like Realm, D, SSD, Samba, and then we will plug in our configuration. This is a key piece right here. So we have to make our realm, which is a term for, in the Linux world, a domain could be called a realm. So when you think of domain in Microsoft, you think of realm in Linux. So our realm is megamooselabsfun.com, and then our KDC, which is the Kerberos Distribution Center. It's the instance of Kerberos for that realm, is going to be this address right here, which is our domain controller. And then the default domain will be megamooselabsfun.com. This is if you wanted to have a different, if you wanted to try to create a Linux trust, a realm trust. That's what you would use this for. We won't be doing that in the configuration. And then these are CPaths and just different ways to represent the domain name. There are certain rules in Linux. One of them is everything is case sensitive. So then we'll get the Samba tools, and then we'll test from the domain joined, or from just the standard account, we'll test being able to look at the file share with different permissions. Then we'll actually join the Linux machine to the domain, and then we'll test SSH with user accounts. And then we'll create a Active Directory group, and then we'll put users inside of that group that will be allowed to SSH to the Linux machine. And then when they have access to the Linux machine, they will have super user rights. It's known as sudo admin rights. So even though they'll just be standard users in Active Directory, we're going to give them admin rights on the Linux server. In the Linux world, it's known as sudo. So we're going to create this group called Linux sudo admins, add in our standard Active Directory users into that group, and then we'll go into the Linux server and add in this bit of code that will recognize this group and then give them sudo admin permissions over the Linux server. And then just a bunch of different testing that we'll do with the Kerberos tickets. In my laboratory prerequisites lab, I showed how to stand up the WAC server, but we'll run over it again real quick in this lab. We'll use a Windows Server 2025 server core image. We'll stand up our WAC server, and then we'll, after the entire infrastructure is set up, we'll add machines to our WAC server and then see how Windows Admin Center behaves. So this is just the code to do it. We download the installer file because we won't have a GUI, and then we launch the installer. Even though we don't have a GUI to download, when we run the installer, we get a GUI, and then these are the steps of the installation that we'll do on the WAC Center. And then from that point on, we'll be able to connect to our WAC Center from any device using this web address. And then we'll also manage everything with Windows Admin Center and PowerShell. So all of those are critical concepts for the curriculum. So that concludes the high-level overview, looking at the code, looking at the prerequisites. We're now ready to begin the configuration. But before we begin the configuration, I just want to demonstrate PowerShell Direct. This is another concept from the curriculum. So on all of these different machines, we have the ability to access them with PowerShell. So I'll do a demonstration. So when you have the Hyper-V PowerShell module on your Hyper-V host, you get a parameter called VM name. We can use that VM name to point towards our virtual machine. The tricky part is credential. If you don't know the IP address and you don't know the host name of the computer, then you can't get logged in. So even if it was domain joined and you didn't know the password, you couldn't get logged in. But at this point in our lab setup, I have renamed all of the virtual machines and programmed in an administrative password, and then saved them in their safe state. I've resumed the domain controller, and now we're going to access it through PowerShell. So I renamed it ANC-DC01, and we're just going to use the default administrator account. We plug in the password. Oops, I typed it in wrong. And now we have a PowerShell session. So do the host name. We are in the domain controller. And then here's all of the IP address information. So this is its IP address that I got from the DHCP server, because it's not a domain controller yet. So you can see how powerful that is. We can remote, if we're connected to the host, if we're on the host, we can PowerShell remote to any of these devices using PowerShell. Just wanted to make one note about storage. So I've stood up 10 of these virtual machines, and I've provisioned the C drive to be 128 gigabytes. And my machine only has 512 gigabytes. So I use dynamically expanding disks to use a concept known as thin provisioning to allow me to create virtual machines with those size disks, even though I don't have the space. So that is a concept from the curriculum known as thin provisioning. If your Hyper-V host runs out of space, the host will stop working and all of your virtual machines will stop working. So when we look at my set of virtual machines, we can see that the Windows Server core images are much smaller than the desktop experience, which is Jun SVR01, for example. It's almost about double the size. And then another thing to note is they will expand. Yahoo-RAS01 is a desktop experience server, and it's grown to about 30 gigabytes. And then AnkDC01, you can see it's starting to grow. So as we progress through the lab, we'll most likely run out of storage and have to destroy a virtual machine to continue on with different parts of the lab. So you could have a computer with a bigger hard drive, use a different hard drive. But in my case, I'm doing everything with a 512 gigabyte SSD. So we're going to start the ADDS configuration by promoting our first server to be the domain controller for the minecraftmoose.com domain. So we're going to program in a firewall rule that allows the server to respond to ping. This is useful during testing. By default, it won't respond to ping. Windows Server won't. So we're going to add that firewall rule, set the static IP address to 192.168.77.7, program in the default gateway and its DNS information. And then we're going to begin the promotion of the server to a domain controller. So in the code snippet I ran, it's just checking to make sure that the role is installed, and then we'll see the bit of code to promote the domain controller. So the output gets mixed up behind the loading bar there, underneath this display name, but the role is installed, so we've begun the promotion process for the minecraftmoose.com domain. Now I'm going to time compress the video here. I'm going to pause the recording while the promotion occurs. Okay, excellent. So the promotion has finished. Now the virtual machine will reboot. So we're going to start resuming our Anchorage servers. And our PA is actually in a different local area network than the Anchorage domain controller. It's in the Linux local area network. Okay, excellent. So this will take just a moment, and then we'll see the login screen. And then we'll begin adding our virtual machines to our domain controller. Excellent. So we've got the login screen. We're actually going to run this bit of code later when we add our privileged access workstation to the domain. We'll get our graphical user interface tools, and we'll observe the site objects being created along with the DNS conditional forwarder. So before we add our machines to the domain, we're going to take our default Active Directory user accounts, which are Megaman and Rush. Since I used a golden image that had 2 local accounts on the server before promotion, it takes those accounts and creates them in Active Directory. So we're going to place them in the same groups as the default administrator and then disable the default administrator user account. Now, Rush was placed in the same groups as the default administrator was. Same with Megaman. And now the administrator account is disabled. So I'm going to log off. So now we'll log into our privileged access workstation and join it to the minecraftmoose.com domain, and then we will manage the Active Directory environment from our privileged access workstation as much as we can. So this this server is in a different subnet, so it got a different DNS address by default. So now we're setting the DNS information to point to the minecraftmoose.com domain before we join it. So after the machine reboots, it will be part of the domain. So we can see here it says sign in to Minecraft Moose. That means it's part of the domain. And we'll sign in as our enterprise admin. So we skipped the part about site objects. So we'll come back up here, and now we're going to create our site objects, place our sites in the default IP site link, and create the conditional forwarder. But we're going to use PowerShell remoting from our privileged access workstation to do the configuration on the domain controller. First, we'll go to Active Directory Users and Computers, and we'll just see the default objects. So here's our one domain join server, our domain controller, the administrator account which has been disabled, and then here is Mega Man and Rush. So to begin configuring these site objects, we're going to use PowerShell remoting. So we'll use the enter ps session command, and we can cheat a little bit since we are logged in as Mega Man, which is a enterprise administrator. We won't have to use the credential parameter, and since the machine is domain joined, it knows about the minecraftmoose.com domain, and it will append .minecraftmoose to the end of the computer name here. So all I have to do is enter ps session ank-dco1, and then we are connected to the domain controller from our privileged access workstation. So before I create the site objects, we'll just take a look at the default settings. So we can see sites. The first site gets the name default first site name. This will represent Anchorage. And we can see our Anchorage domain controller is inside with an instance of the NTDS settings. If we right click here and go to properties, we can see it's a global catalog server. So now we're going to build the Eagle River and Nome site. And then as we expand the domain later in the lab, we'll see the domain controllers placed in their sites. So we'll come back to our command line. We'll grab this bit of code. And so now we've created all of our site objects and placed all of the sites in the default site link. And we also created our conditional forwarder to moosewyre.fun.com. So we'll come back here, go to refresh. Now we have our new sites. There's nothing in them yet. But if we go to Intersite Transports, IP, right-click, Properties, Nome, Eagle River, and the default first site, which is Anchorage, are now in the default IP site link. So they will be designated as bridgehead servers since they're the only domain controllers. And then they will replicate with each other by default every 90 minutes. 180 minutes. Just say that one more time since I misspoke. They replicate every 180 minutes. So now we'll create our user pool, join our machines to the domain, and then create a custom organizational unit and move the computer objects inside. So I'll grab the bit of code to build the default user pool. So this bit of code will build the organizational unit, create all of the Active Directory users, place them inside, and then build that custom group, place all the users within that group, and then place that group inside the custom organizational unit. So now we can see all the bosses from the video game Mega Man 1 are now users in Active Directory domain services. We'll come back to our privileged access workstation, hit refresh. Now we can see our new custom organizational unit with all of the user objects and then this group that has all of the users inside of it. These users are also programmed with properties, descriptive properties. So the description is Anchorage Programmer, Office Anchorage, Company, MinecraftMoose.com, Department Programming, Job Title Programming, Programmer, we will sync all of this information to Entra ID along with the password hashes of the user accounts. And then we'll test that in the cloud. So we'll join now that we have our user pool created, we'll join the rest of our servers to the domain. So I'll start with Ank server 01. This machine only had its computer name changed and everything else is set to the default settings. Okay, after the machine reboots, it will be part of the domain. So now we'll rinse and repeat on the WAC server, which is Windows Admin Center. So at the very end of the lab, we'll come back, stand up an instance of Windows Admin Center, and then see how it behaves in the environment. We'll get logged in here and then join our Windows Admin Center server to the domain. Excellent, and then when the machine reboots, it will be part of the domain. So now we've added Ank WAC 01, Ank Server 01, and Ank PA 01 to the domain. So now we're going to bounce over to our privileged access workstation. We have our PowerShell session back to our domain controller. And we'll take a look at the computer list. So we can see Ank WAC 01, Server 01, PA 01 in the DC. And then we'll also look at the user pool. You can see all of our users, cutsman, gutsman, electman. And then looking at the graphical user interface, we'll come over to Active Directory Users and Computers, right-click, refresh. We'll see we get a new, we'll see our computer objects are now inside of the computer's container. So now we will create an organizational unit and place the computer objects inside of that organizational unit so that we can apply group policies to these computers. So I'm going to create a new organizational unit and then move all of our computers' objects to that new organizational unit. So here I am on my privileged access workstation. Back to my PowerShell remote session to the domain controller. I'm going to create a new organizational unit and then move all of those computer objects to that new organizational unit. So we hit refresh. Now we see the new organizational unit and the computers have been moved there. So now we have a group of computers in one organizational unit and a group of users in the other. And now we can leverage those organizational units to apply group policies. Now we'll create the group policy objects and do some testing before we expand the lab environment. So I went over this code a bit earlier in the video. So this entire PowerShell code block is going to download a custom wallpaper from my GitHub repository, share it out on a file share, and then create a group policy object, configure the group policy object, and then set the group policy object. We're going to link it to the organizational unit. So we'll take a look at the default group policy objects. And what we find is the default domain controller policy and the default domain policy. So now we're back here in my PowerShell session to the domain controller. We're going to paste this bit of code to configure the group policy object. So it's downloaded the image, it's created the file share, configuring the object. And now the group policy object has been created and attached to that custom organizational unit that our users are a part of. So hit refresh. Look at our group policy objects. We have this new group policy object called set wallpaper. When we look at the Entra synced user organizational unit, we find that the group policy object is now attached to that organizational unit. And then in this case, we were able to use PowerShell to configure a user policy using an administrative template for the desktop. And then you can see inside the desktop wallpaper setting, we specifically set the path of the custom wallpaper that we downloaded and then shared out on our file share. So when we look in file share, or excuse me, in File Explorer, we can see on the domain controller our file share, and then here is the wallpaper that will be applied to those users that are in that organizational unit whenever they log into a domain joined computer. So that is a user group policy object that we just created. Now we are going to create a computer group policy object, but we're going to use the graphical user interface. So I'm going to right click on our organizational unit that contains all of our computer objects, select create a GPO in this domain, and link it here. Call it allow MCM MooseWire dev RDS users will be the name of the group policy object. So we get a brand new group policy object. It has thousands of settings. And we're going to go in and change the computer security settings. We'll just do a basic computer group policy object to show how we can use them in our lab environment. So we're going to Policies, Windows Settings, Security Settings, and Restricted Groups. We're going to add a group. And when we created our user pool, we created that custom group, put all the users inside of that group. Now we can use that group here. So we come in here, add it one more time. So the members of this group will also be a member of the remote desktop users group on the server. So the servers have their local accounts and groups. One of them is the remote desktop users group. We'll place all of the users inside of that remote desktop users group. So when we look at the group policy management console, we now have two group policies, a computer group policy object and a computer group policy object. So now to demonstrate the group policies, we'll try to connect to ANC server 01 with one of the Mega Man boss accounts. So we'll try Cutsman. Oh, he has a different password. And then we get this quirky error that says to sign in remotely, we need the right to sign in through remote desktop services. So we'll come in, sign in as Mega Man. So Mega Man is an enterprise admin and has other administrative rights, so I'm allowed to remote desktop, but Cutsman had a problem. So we're going to take a look at the group policy that is applied to the computer. And what we can see is only the default domain policy has been applied to the computer. So we need to update the group policy. So what we'll do in this example is use the GP update /force. And now we are forcing the domain controller to get the newly created group policy object from the domain controller and then apply it to this server. And then we get this nice message that the computer policy has been updated. And now we can see the allow MCM MooseWire dev RDS users group policy object has been applied to this computer. And then we can check by checking the local groups on the server and looking in the remote desktop users group, and we can see that this group was added by group policy. So now when Cutsman attempts to log in, he will be a member of the remote desktop users group on the server, and he'll be allowed to log in. Cutsman is also in the Entra Synced Users organizational unit, so he will get a custom wallpaper applied to his desktop when he logs in. So not only did we solve the quirky login problem with our computer group policy object, we've now applied a custom wallpaper with a user group policy object. And so these are simple examples that you can then build upon to test the concepts in the curriculum. And so you can see that Cutsman is not an administrator. And he's not even allowed to restart the virtual machine. So we'll reboot it with our administrator account. Now that we've set up our root domain, joined computers to our domain, and have a set of test users, we can begin expanding our domain. And we'll also see how we can leverage group policy objects by applying them to sites. Just a short recap here. We have built our first domain. It is a root domain. And now we will be expanding the domain to our tree domain and our child domain. Once we stand those up, we'll create a second domain called megamooselabsfun.com and then connect those root domains by a two-way forest trust. So I'm going to save some of these virtual machines while we expand the domain, and we'll come back to them in just a bit. So I'm going to begin with the moosewyre.fun tree domain. So we're going to program in a firewall rule that allows the server to respond to ping. Again, this is useful for testing. And then we'll set the static IP address, program in its default gateway, and then point DNS to the minecraftmoose.com domain before we promote the server to be a tree domain in the minecraftmoose.com domain. Before we promote our second domain controller, we're going to take a look at the Active Directory database and how the partitions are configured. So here I am on the Anchorage domain controller. We're going to use ntds util. Then we're going to activate an instance of ntds. Then we're going to go into partition management, connections, connect to server anc dco1. Then we have to go back one and list. So we can see the schema partition and the domain partition. And then we can also see the DNS partitions. When we create the tree domain, we will see another partition added into the database, but they will share this schema partition, which is minecraftmoose.com. That's a key point in the curriculum. So as we stand up a second forest, which will be megamooselabsfun.com, it will have a separate schema because it is a separate forest. So even though we have a name change between minecraftmoose.com and moosewire.fun, they will share the same schema. So we're now ready to promote our second domain controller. So we'll program in our firewall rule the networking information. Now we are going to promote this server to be a domain controller for moosewire.fun, which is a tree domain for minecraftmoose.com. This will take a bit of time, so to time compress the video, I'm going to pause the recording while the promotion is underway. While we're waiting for the promotion to wrap up here, I just want to make a note, and I'll make a note of this again, that as we stand up these domain controllers, especially when they are tree domains in the child domain, we have to ensure a full sync between the environments. Some of the administrative tools might not act properly on the privileged access workstation. There's some other funny things that can happen until the full sync happens. So the configuration is good, it's solid, but then you'll start testing the environment and things might not work at first because that sync has not really happened yet. So the longer that the environment is up and running, the better chance that you have it will sync on its own, but then we'll use different management tools to force the sync during this demonstration. So the promotion has finished, and now the server will reboot, and it will be promoted as the domain controller for moosewire.fun, which is a tree domain of minecraftmoose.com. This will take just a moment, starting up the group policy services, I think. Be just a bit of a pause here. While we're waiting, we'll bounce over to our privileged access workstation. So we'll take a look at how the trusts and the sites and services have been affected by the tree domain. So first we'll go into Active Directory Sites and Services. And we'll hit refresh. So here's our Anchorage domain controller. And now when we look at our GNOME site, we have a GNOME domain controller, which also is a global catalog server. So we created these site objects, the Eagle River being the example. There is no Eagle River one yet, so we just have this empty servers folder. But then we created the tree root trust, and now, we created the tree domain, and so now we have added our domain controller in this site, and we specified that during the promotion of the domain controller. So one problem you can notice in NTDS settings, there is no connection object. So when we look in Anchorage, when we have this connection object here, this is where you could modify the replication schedule, but it's not here. So we'll take a look. What we need to do is force a sync to make sure that everything is working properly. So now we can see that we are back on our MooseWyre.fun domain controller at the login screen. So the promotion has finished and we're here at the login screen. So I'm going to finish off the configuration and then we'll take a look on the privileged access workstation. Oops, I typed that in wrong. And rather than doing it directly on the console, we'll do it from the privileged access workstation. So just to get that idea that we're managing as much as we can from the privileged access workstation. And real quick, we'll just look at the partitions. And we can see now that MooseWyre.fun has been added to the ADDS database partition set. And so what's important is that they share the minecraftmoose.com schema. There is no MooseWyre schema. The schema that it uses is the minecraftmoose.com schema. So we will manage the environment from here, but first we will make sure that we have a proper sync. We may need to go back to the GNOME domain controller, but we'll do all the sync commands from the Anchorage one. So we kind of noticed a problem in the GUI with replication, and this output also has some indicators that maybe the replication is not going well. So what we can do is force the replication going to the Anchorage domain controller. Which is to be expected because we're just running the sync from ourselves. But then we also need to see if we can sync to the GNOME DC01 MooseWyre.fun domain controller. So now you can see we get the sync occurred. It appears that there's no errors. So we'll come back to our sites and services. Hit refresh. Now we can see we have our connection object. So before we start using the management tools, I just want to mention again, they might not work at first. So the configuration is solid, it's working, but as we start using the management tools to manage the MooseWyre.fun domain and the child domain, if everything is not syncing properly, we might get some errors in the tools. So another way that we can check that syncing is good is we can actually right-click on these NTDS objects, and we can replicate from the selected DC, and we can also replicate to the selected DC. So we'll do both options just to make sure that everything looks good. Excellent. So the first tool that we'll test is DNS. So we're going to go to the GNOME dco1.moosewire.fun server. It finds an instance of DNS. We're an enterprise admin, so we're allowed to have access to this instance of the DNS, which is moosewire.fun. You can see here's the DNS record for our GNOME domain controller. And then we will set up our conditional forwarder. And set our default administrator accounts. So we're going to use PowerShell remoting to access the GNOME domain controller. Now I'm logged into the moosewire.fun domain controller, gnome-dco1, as Megaman at minecraftmoose.com. Now what we need to do is add our conditional forwarder. When we look back at our GUI, hit refresh, we can see now we have a conditional forwarder to minecraftmoose.com. So from our Anchorage privileged access workstation, we're looking at GNOME's DNS. And then we're also PowerShell remoted into GNOME's domain controller, and that's how we configured the conditional forwarder. Now we're going to take the default Rush and Megaman accounts. These are Rush at moosewire.fun and Megaman at moosewire.fun, and place them in the same accounts as the default administrator in the moosewire.fun domain. And the biggest thing to notice is they are not part of the enterprise administrator groups. So by default, the administrator, since this is a tree domain, it is not the root domain, the administrator is not placed in the enterprise administrators group. And so this proves that concept that the curriculum pushed us pretty hard. So this is a tree domain, even though they share the same schema and all of that. These default administrator accounts are not enterprise admins. So now we will build the default user pool for moosewire.fun. It's the same bit of code, but just modified so that the users are bosses from the video game Mega Man 2. So we've got Bubble Man, Air Man, Crash Man, Metal Man, Flash Man. So before we create the user pool, we'll finish taking a look at the graphical user interfaces, just making sure everything is synced and looks good. So we'll take a look at Active Directory Domains and Trusts. And here you can see we have moosewire.fun. When we take a look at the trust settings, it is a tree root trust to minecraftmoose.com. It is not an external trust. It's not a forest trust. It is a tree root trust. And this is the type of trust when the domains share a schema. And then we can also look at it from the Minecraft Moose side. Everything is looking pretty good. So this tool can be a bit finicky until everything syncs. So this is Active Directory users and computers. We're connected to the minecraftmoose.com domain. but we want to connect to MooseWire. So we'll change domain. It actually knows about it, it finds it, and depending on if your environment's been up long enough, if the syncing is good enough, you might get an error message here. Let's see what happens. And it's found it. So we ensured that we had good syncing, our replication objects. We gave it a bit of time to sync. And now we can connect to the moosewire.fun domain, and we can see there's no Entra synced users. There's only the default users, and the default administrator account has been disabled there. So since Megaman at Megaman@minecraftmoose.com is an enterprise admin, he's also allowed to administer this domain. So now we are PowerShell remoted into the GNOME domain controller, and we'll run this bit of code to create our custom organizational unit, our custom user pools, set their properties, and then place all of those users inside of a custom group. So now we can see all the bosses for Mega Man 2 are in that custom group. So we'll come back here, hit refresh. Here's our custom group, and then all of the users from Mega Man 2. So we're now ready to begin the child domain. Get on to my host here. And we'll have just enough memory to get him booted up. So again, the domain controllers are instances of server core, so they're command line only. And then we're using PowerShell remoting and the graphical user interface tools from our privileged access workstations to manage everything. So we're going to set that same firewall rule that will allow the server to respond to ping, and then program in the networking information, pointing DNS to the root domain, which is this 192.168.77.7. That's the domain controller in our root domain. Now we will promote the server to be a domain controller, and you'll note it's a child domain with the parent domain being moosewyre.fun. And then I will pause the recording to time compress the video while we wait for the promotion to finish. Excellent. So the promotion has finished. And now the server will reboot, and now it will be the domain controller for the child domain, dev.moosewyre.fun. And again, this first time that after the promotion, it takes a second to get to the login screen. But we'll bounce over to our privileged access workstation and just kind of see how the site objects have been affected. So we'll hit refresh. So we'll look at the default site. There's Anc DC01. Look at the server GNOME DC01. And now we have Eagle River DC01. And they all have their instance of NTDS settings. And it is also a global catalog server. One issue right now is there are no replication objects in the NTDS settings. So we're going to force replication and then make sure our NTDS settings look good before proceeding on with the lab. So we'll wait for the login screen before proceeding. All right, so we are back at the login screen. So we're going to bounce over to our privileged access workstation, and we'll hit refresh. We still don't have our connection objects. So we'll take a look on the Anchorage domain controller. For these, I'm going to run them directly on the console. But we'll run the same summary and show REPL. And you can see we have some warnings. So the management tools really won't work from the privileged access workstation until we get all of this syncing. Eventually it will sync, but we're going to force the replication. So first we'll replicate to the new domain controller. And this command tells the Eagle River domain controller that it's ready to replicate with everybody. So we get this nice message about no errors. We'll go ahead and sync it, do the same process for GNOME. Looks like no errors. And Anchorage. So the first thing we're going to notice is the connection objects are now here. So go ahead and hit refresh. I'll just refresh the entire deal. Now we've got our connection objects. So now we could control the replication schedule. And we'll also try to run it all over the place. So it looks like we have pretty good syncing. So we can also right click here, replicate, and so we get an error. So the configuration is fine. We're just waiting for everything to sync. So if we started to use the management tools, we'd run into problems. So we're going to go ahead and make sure we get good output from these. So this is the good output. Active Directory Domain Services has replicated the connections. So we'll do that in Eagle River as well. and we get the error. So now we'll do replication from the Eagle River domain controller. We'll go directly onto the Hyper-V console. We're getting good output, and I've got one more going all the way back to Anchorage. And here, replication access was denied. So I do appear to be getting this access denied error. So we'll log out as the dev Megaman, and we'll log in as the enterprise administrator, which is Minecraft Moose Megaman. And then we will run the configuration commands from Megaman. Forgot it. Make sure I got that typed. And so now we're logged into the dev.moosewyre.fun domain controller with the enterprise admin account, which is megaman at minecraftmoose.com. So then we're going to try the same sync commands. Oh, I don't have my enhanced session. I can tell by the zoom. So we'll come in and get our enhanced session. And the enhanced session allows me to copy and paste. So we're logged back in as Minecraft Moose Megaman. We'll begin doing all the syncing. We'll pop back over to our privileged access workstation. See if we can't get better output. Excellent, and now we've got great output. So it might have been the different rep admins that we were doing. It might have just been giving it a bit of time to sync. But now we appear to have a good sync between our root domain, our tree domain, and our child domain. And then just a quick recap. So we've created the root domain, the tree domain, and the child domain, and their associated trusts. Now, our next step will be to create the root domain for megamooselabsfun.com and a two-way forest trust. So the first tool we'll take a look at is Active Directory Domains and Trusts. When we look at moosewire.fun, we now see dev.moosewyre.fun. When we look at the trust value, we'll see it has a parent trust with moosewire.fun. When we look at the properties of moosewire.fun, we can see the child trust to dev.moosewire.fun. And then the tree root trust to minecraftmoose.com. And then the only trust between minecraftmoose.com is to the moosewire.fun domain. So moosewire.fun actually has two trusts connecting him, a child trust and a tree root trust. Before we look at the other tools, we'll look at the schema, we'll look at the Active Directory database and how there is a new partition and how they share a schema with the other domains. So it's ntds util, activate an instance of ntds, partition management, connections, connect to server anc dco1, go back one, and list. Now we can see the dev moosewire fun partition and the moosewire.fun partition, and then also the minecraftmoose.com partition, but they all share the minecraftmoose.com schema. So there is no dev moosewire schema. It's the Minecraft Moose schema that those domains use. And then we can also see some other DNS partitions that have been added. So when we started with our root domain, we had 4 partitions. By the time we added our tree domain and our child domain, when you count the DNS partitions, we have 8 partitions in our Active Directory database. So we'll finish looking at the tools from the Privileged Access Workstation. So the next tool we'll look at is DNS. With 1 gigabyte of RAM, this may be just a bit buggy. So we're going to connect to a DNS server. So now it's found the dev.moosewyre.fun domain. We can see our domain controller is now in a parent, the child domain, its DNS shows up in the DNS manager. So here's GNOME DNS, Eagle River DNS. And we'll connect to Anchorage. So here's all the records for our DNS servers. We haven't added any servers to these domains, so they don't have very many records except for the domain records, very many host A records. But now we can manage all 3 DNSs from our Privileged Access Workstation. And then the last tool we'll look at is Active Directory Users and Computers. And this one can be a bit finicky when we go to change the domain. Excellent, and it finds the dev.moosewyre.fun domain. And you can see there's no custom organizational units yet. And now we'll finish out the configuration from the Privileged Access Workstation. dc01.dev.moosewire.fun, and we'll use the enterprise admin. Oops, host name, and we can see we are on the Eagle River domain controller. So we'll build the default user pool. And this will be the bosses from the video game Mega Man 4. So Toadman, Brightman, Feralman, Skullman. So we're also going to create a custom organizational unit, place all of those users inside of the organizational unit, the custom group, and now we can see all of the Mega Man 4 Active Directory users are in that group. So we'll come over to our privileged access workstation, hit refresh, and we can see our custom organizational unit, and then the custom users inside. So here's Skullman, and you can see he is a programmer, and he is in Eagle River. So now we're going to add a computer to the domain. So in order to proceed on, we will need to adjust our memory just a bit. So all of that syncing and the configuration is going on with the domain controllers. I like to have them have 2 gigabytes of memory. So now we're going to turn them off, set them to 1 gigabyte of memory, and then join the Eagle River server to the dev.moosewyre.fun domain. So I'm going to be a bit aggressive and just turn them off. And we will set the memory to 1 gigabyte. And just start it right back up. And we'll do that with each domain controller. I give a few extra minutes there just to get a head start on any syncing problems. Then we'll bounce back here and just force replication. Make sure we're not getting any errors before proceeding. So now all the domain controllers are running off 1 gigabyte of RAM. So now we can start up our Eagle River server. And we'll get it joined to the domain. So this needs to be, oh, that's fine. Now the machine is added to the domain. So we'll come over to our privileged access workstation. We'll need to reconnect to our instance of Active Directory users. When we adjusted memory, it lost connection. So we will just change domains real quick. We'll use browse this time. Excellent. And now we have this computer ER server 01. So now we'll use a PowerShell remoting session to access the Eagle River domain controller. Since I'm an enterprise admin, oh, I spelled this wrong. Oops. Since I'm an enterprise admin, I won't have to enter my credentials. So now we will disable the administrator account and make dev.moosewyre.fun, rush at dev.moosewyre.fun will be placed in the domain admins group, but you'll notice they're not in the enterprise admins group. So that's only in the root domain. And then we'll look at our PA, go to computers, and we see we've got our server. So now we're going to stand up our second forest and create a two-way forest trust between the domains. So I've got 6. I think we'll just barely pull this off. Excellent, and then we'll do the configuration with 2 gigabytes of RAM, drop it back down to 1, and then we can experiment with different servers. So the configuration is almost identical except for the parameters of the networking values. So we're going to come into this domain controller, program in a firewall rule that will allow the server to respond to ping, program in its static IP address, gateway, point DNS to itself, and then promote it to be a domain controller for the megamooselabsfun.com domain. And then I mentioned this before, but Megamoose Labs Fun is NetBIOS name is appended by 1 character, so the NetBIOS name is Megamoose Labs FU. So it's not a typo, it's just how NetBIOS has a character limit. And then in order to join the Juno server to the domain, I'm going to save the state of the Eagle River server. And then we'll need that, just a little bit of memory to get him joined to the domain. So after we promote, after the promotion finishes, we will drop the memory back down to 1 gigabyte and then join the server to the domain. The promotion is underway. I'm just going to check my disk space, and I appear to be doing okay. There may be a point in the lab where we have to destroy a virtual machine, but for now, we're doing okay. So I will time compress the video here while we wait for the promotion. So I'll pause the recording. Excellent, so the promotion has finished here. So we'll let it reboot, and then after it has fully rebooted, we'll shut it down, adjust the memory to 1 gigabyte, and then start up our server. So that'll take just a moment here. So now we'll just sign in for good measure here. And before joining, the server will finish the configuration. So we're going to disable the default administrator and make Rush and Mega Man put them in the same groups as the default administrator. So what you will notice is there is an enterprise admins group because this is the root domain. Also, if we use the NTDS util, activate a instance of NTDS, partition management, connections, connect to a server. Oops. Connect to server Inc. DC01. I did that wrong. So activate a instance of NTDS. Partition management. Connections. And Jun DC01. Then go back one and list, and we can see this schema partition is megamooselabsfun.com. So this is a new forest with a new schema partition. So we'll get logged back in as Mega Man. And we'll build our final user pool set, which will be the bosses from the video game Mega Man 3. So Hard Man, Top Man, Spark Man, Gemini Man. And you can also notice the net BIOS name. You can see how one character was appended from my actual domain name. Oh, and I don't have my enhanced session, which allows me to copy and paste. So I'm just going to refresh here. And then we've got all of our Active Directory user accounts from Mega Man 3 placed in the MML RDS users group. So we're now going to turn off the domain controller and adjust the memory to 1 gigabyte. And this should allow us to start the server. So that's not bad. We have 8 virtual machines running on 1 gigabyte each. So that's pretty good. Given that I have 16 gigabytes of RAM. So if you have 32, you could probably have all of them on. And this is a default Windows Server 2025. It has my golden image. So we'll also have the desktop background wallpaper, the custom one, and those 2 user accounts. Now, after the machine reboots, it will be added to the domain. So the last part of the Active Directory Domain Services configuration will be to set up the two-way forced trust, and then we'll use our servers to do testing. So one of the requirements for a two-way forced trust is you must have DNS name resolution between the forests. So I'll achieve this with conditional forwarders. So on Jun DC01, I have to create a conditional forwarder to minecraftmoose.com. And now we have the conditional forwarder set. When we ping minecraftmoose.com, it pings the domain controller. So we'll need the same conditional forwarder from the minecraftmoose.com domain. So we'll create that on ankdc01. And we'll do that from our privileged access workstation. So I'm PowerShell remoted into the domain controller, and now I'm configuring the conditional forwarder to megamooselabsfun.com. Now from the privileged access workstation, we'll test the DNS name resolution. Oops, forgot the ping command. And we can see it finds the domain controller in the megamooselabsfun.com domain. So now that we have DNS resolution set up, we can set up the forced trust. You can do this with the graphical user interface, but I've scripted it out here to do in PowerShell. It's a little bit tricky. In this case, I used objects from the system.directory services. And then they have methods that are programmed into these objects, which is how I was able to get some of this information. So all we need to do is just copy and paste this onto the Juno domain controller. He's being just a bit buggy. I'm going to get a fresh session. And we should get some nice verbose output at the end that the two-way forced trust was created. So now we'll bounce over to our privileged access workstation and go into sites and services. Hit refresh, or excuse me, we go to Active Directory Domains and Trusts. And when we look at minecraftmoose.com, it has a trust. It is a forest trust to the megamooselabsfun.com domain. So earlier we built this group, which is a domain local group. Domain local groups are allowed to contain members from anywhere in the forest. And when we create a two-way forest trust, we can actually add members from the other domain to this group. So we'll just do advanced search, just do find now. And we can see all of the users in the other domain. So we'll pick we'll do Hardman. So now Hardman is in this group, but he is not from minecraftmoose.com. He is from megamooselabsfun.com. So I'm actually going to remove him. We'll hit apply just to prove that it works. So we have just added a user from another forest into this group. That's what that little red up arrow is about. And then we actually are only limited to certain information. This has to do with the global catalogs, but essentially this is all the information that we will get. So for now, I'm just going to remove him. Excellent. So we've stood up just to do a recap, we have stood up our root domain, we created the tree domain and the child domain, and now we've created a two-way forced trust between our two root domains. And so now what we will do is we will create a group called megamooselabs DL-RDP Cross Forest, and then we will add members from the other forest into this group, and then we'll attach it to a server and then log in with megamooselabsfun.com accounts in minecraftmoose.com. So we're going to give users in the other forest remote desktop access to some servers. So run this bit of code. run the entire thing. I'll create the group and add the members. I will need credentials to do this. So I'm going to do it directly from the PowerShell console, or excuse me, the Hyper-V console. And we can attempt it from the PA. I'm pretty sure it will work. So we will use a PowerShell session to create everything. So I'll connect to the domain controller. Okay. Oh, I have a typo. So we'll try that again. Just got a small typo there. Excellent. And now all of the users have been added. So I will update that on my GitHub repository, but essentially we found the users in the other forest and then added them to this group. And so now when we hit refresh, we can see our cross-forest group has members from another forest. So Mega Man from Mega Moose Labs Fun, Top Man, Shadow Man, and Gemini Man all now are in this group that we can use to grant access to resources within the domain. So a global group is a bit different. It can have members from anywhere in the forest, or excuse me, it can only have members from the same domain in that global group, but the global group can be assigned to resources anywhere in the forest. Whereas the domain local group can have users from anywhere in the forest, but can only be assigned to resources in its domain. So now we'll use an example of this. So we're going to shut down one of these servers. We'll shut down the Juno server. We're going to power on the Anchorage server. And then I'm going to add that group to the remote desktop users group. So we could do it manually, which I'll show you, but we're actually going to do it with a group policy. And this will be a solid test of the environment. So our goal is to have the users from the other domain access this server. So now we have a group that contains users from another forest, and it's a domain local group. So what we could do is go into the server, go into its local groups, and we could just add the group manually wherever we want. So we could add it here. And it finds the Megamoose Labs group. So this group contains users from the other side of the forest. So now if we applied this, users from that other forest, the Megamoose Labs fun.com forest, could access this server through remote desktop, which is a minecraftmoose.com server. So I'm going to cancel. So instead of applying it manually, we're going to edit the group policy and then apply it. So we'll bounce back over to our privileged access workstation, and then we're going to go into group policy management. So we're going to find our group policy. Go back to the same setting, which is a security setting, and restricted groups. We're going to add a group. It's going to be this cross-domain group. Add it one more time. We're going to add it to the remote desktop users group. So now we've updated the group policy. So now from our target machine, which is the Anchorage server, so here we are looking at that same group. We can see it's not in there yet because the group policy is not updated. So we're going to update the group policy by gp update force. Oops, I spelled that wrong. So do gp update / force. Oops, spelled that wrong too. So the computer policy is updated successfully. So we'll see if the group has been placed here. And it has. So rather than adding it manually, we used a group policy that we could then apply to more than one computer. Instead of just changing it manually on each computer, we've used centralization to then, the concept of centralization to apply the setting behind a single pane of glass, behind our privileged access workstation. We altered the group policy that then added this group. So we're going to sign out. So we'll try to sign in with Topman to the Anchorage server. So we are going to sign in as top man at megamooselabsfun.com. So we've officially granted a user in another forest remote desktop access to a server in the minecraftmoose.com domain. Oops, so who am I? Top man at megamooselabs.fun. Oops. And we can see the user domain is megamooselabsfun.com while we are on a minecraftmoose.com server. After reviewing some of the material, I realized I missed a key demonstration. So after the recording, I've come back in. So when you're watching the video, you'll notice the time skips around. There's this John Linux machine, but that's because I've come back at the end of the recording. And it's just to demonstrate attaching the group policy object to a site. So we're going to connect into our privileged access workstation. And we're going to go to Group Policy Management. And we can see our sites and all of our group policy objects and where they're attached. So we're going to attach a link an existing group policy, the set wallpaper policy, to the Eagle River site. So this is a bit dangerous because it applies to every user that is in that site. So here we were using organizational units as a boundary to where the group policy objects replicated. Here the site is the boundary, so anything in the site will get this, any user in the site will get this group policy object. So now we'll bounce over to our test server, which is Eagle River Server 01. So we'll connect in. We'll use the domain administrator account. And we notice we haven't got the custom wallpaper yet, but that is because the group policy has not been applied yet. So we'll come in here, see what group policies have been applied. And we'll see that just the default domain policy is the only computer group policy that has been applied. So we'll do GP update force. We didn't get the group policy, most likely because we have to sync between all of the forests. So I'm going to go ahead and run a sync to the Eagle River domain controller, the GNOME domain controller, and myself at the Anchorage domain controller. And then we will run GP update one more time. go ahead and do a reboot as well. Sometimes it could take a moment for the group policy to sync all the way from the root domain to the site. So when we made the group policy, it was only applied to users in that organizational unit, which were the bosses from the video games. But when we attach it to the site, it will include Mega Man as one of those users that get the group policy object. So when we log in as Mega Man here, we'll get a new wallpaper once the group policy object is applied. So we have to make sure it's synced and then gets applied. So we'll do a test login here, and we can see that the group policy object has been applied. So that's pretty neat. From the root domain controller, we made a group policy. We can't attach it to any organizational units related in the dev.moosewyre.fun domain, but we can add it as a site and then attach group policies to the site that will then get pushed out to the computers. And we can see now the group policy has been applied, but this one is actually a user policy. So it's a bit further down in the output. So I was looking at the computer earlier, but this is where the set wallpaper group policy will be applied. So that concludes the initial configuration for the Active Directory Domain Services environment. So now we have a solid environment with 4 domains, 2 forests, and a whole bunch of users that we can test the concepts from the curriculum. So our next goal will be to sync the users from the 4 domains to one Entra ID tenant, and then we will join a Linux server to the domain and then check out Windows Admin Center and Server Manager. So to begin syncing, I want to get some memory back. So I'm going to save the Juno server. And I'm also going to save the state of the Anchorage server. So to begin the Entra Connect configuration, we'll start up our Entra Connect server. And I'll just do a quick recap of the infrastructure. So MCM Entra Connect is in the Linux domain, or excuse me, the Linux local area network. So it will not be in the same network as the Anchorage domain controller. So bring up this diagram real quick. So this is where the Entra Connect server will be on the right here, and the other servers have connectivity to the Entra Connect server. So the idea is we're standing up our Entra Connect server to sync our forests to our Entra ID tenant. So the information, the kinds of information that will be synced will be password, hashes, and then user properties, or whatever we specify during the Entra Connect installation. So the idea is we'll stand up this Entra Connect server, allow it to talk to our domain controllers. They will then sync that information to Entra ID, where it will create cloud accounts that we can attach resources to, like Microsoft licenses. And then those users can sign into resources with their same passwords that they have in Active Directory. So the password hashes will be stored in Entra ID. So if a cloud user comes along and signs in, it runs through the hashing algorithm, and if it's a match, then Entra ID authenticates them. So I've come through and put any servers not related to this lab in the saved state. So I've saved the Juno server, the Eagle River server, pretty much all of the servers, but I've left the domain controllers on so that they can sync to Entra ID. So we're going to connect to our Entra Connect server and get it joined to the minecraftmoose.com domain. So this virtual machine is in a different subnet, so it got a different DNS address through DHCP. So we have to point the server to the minecraftmoose.com domain controller before we join it to the domain, and then we'll use this add computer command to join the computer to the domain. So we're going to log in as Megaman, which is the enterprise admin account. So we're going to go to entra.microsoft.com. And use our cloud admin account. And the first thing we'll notice about my lab environment is there is only one user, and that is the user account we just logged in with. So the goal will be to sync our user pools from our 4 domains into our Entra ID tenant. And then another note about the domain names. So I have purchased the domain names moosewire.fun, minecraftmoose.com, megamooselabsfun.com, and sync them to my Entra ID tenant. So what that allows me to do is create users and then attach different domain names that I have added to my domain to then create the cloud accounts. So in order for Entra Connect to work like it will in this lab environment, you need to own the domain names that you used when you set up your Active Directory Domain Services environment. But what we are interested in is Entra Connect, specifically Connect Sync, and this is where we will get the installation file. So you'll notice some sync information from some previous tests. But for now, we just want to get the installation file. Used to be able to get it from a public domain, but now they want you to log in to the Microsoft Entra Admin Center to get the .msi installation file. And then it is a requirement for Entra Connect to be on a desktop experience version of Windows Server. So we're going to start the installation. Before we begin, we must make sure that we have DNS resolution to our forests. So we'll ping minecraftmoose.com. We have DNS resolution. And we also need to ping megamooselabsfun.com. And then we have DNS resolution. So first we will install the application and then configure the settings. So we'll go into Customize, take a look at some of the options. You could specify a custom install location, use an existing SQL server or an existing service account, but we're going to leave all of the defaults. Now after the program installs, we'll configure what we want to sync to Entra ID. Okay, excellent. So we've finished the installation of Entra Connect, and now we're going to configure the settings for our lab environment. So we're not worried about storing password hashes in the cloud, so we're okay with using password hash synchronization, and this is the concept that we were just talking about in the diagram here. So we're going to select password hash synchronization. And then next we will pick enable single sign-on. And then plug in our cloud admin account. So Windows Server will be unhappy about some of these URLs, so we have to add them to the trusted site list. So now that they've been added, when we come through the second time, the authentication window will work. And then we'll use our same cloud admin. Okay, excellent. And now it's asking about what forests we want to sync to our Entra ID tenant. So it finds the minecraftmoose.com domain. So we'll plug in a enterprise admin for that domain, which is Megaman. Make sure I got that in there right. So now it found the forest, and we get this green check mark. So now we need to add the second forest, which is megamooselabsfun.com. And then it will also want the credentials. So we'll use the NetBIOS name, which is one character appended. So it's megamooselabs.fu, and then Megaman. And now it's found the second forest. So now we have made communication with the two forests from this Entra Connect server. So we click Next. Oh, excuse me. Excellent. And now it's found the Active Directory UPN suffixes and the Microsoft Entra ID domain, and it's verified them. So we're going to select the on-premise attribute to use as the username, and we're going to use the user principal name from Active Directory. So this all looks excellent. So we'll click Next. So the first domain it asks us about is the megamooselabs.fun domain. Then what organizational units would we like to sync? The default is pretty much all of them, but we are only going to sync our custom organizational unit that we made earlier in the lab that contains all of our Active Directory user accounts. These are the bosses from Megaman 1. So then we have to select our second domain, and this is an important point in the curriculum. So minecraftmoose.com is one forest that has a tree domain, which is moosewire.fun, and a child domain, which is dev.moosewyre.fun. So this root domain just has the one domain, and that's it. This forest has these different domains, and they all share the same schema. So, and in this particular case, with minecraftmoose.com and moosewire.fun, there is a name change while sharing the schema. So in each instance of Active Directory, we decide which organizational units we want to sync. And we're just going to do our Entra synced user custom organizational unit. This one contains the bosses from Megaman 4. And then we'll do the same for Minecraft Moose. Entra synced users, this is Megaman 1. Entra synced users, these guys are Megaman 2. So we've selected the organizational units that we want to sync to Entra ID. So we'll leave the top one default, where users are represented only once across all the directories. And we'll choose a specific attribute, which is the MSDS consistency GUID. I'm pretty sure that's the property it chooses if you let Azure manage the source anchor. But this is also from the curriculum that this is a good property to use because it's immutable during the life of the object. So we'll click Next. We could filter users and devices further, but in this demonstration, we'll just click Next. And then we could also set a few more settings here, like group write back, password write back, but we'll leave all of the defaults, and we'll just notice that password hash synchronization is checked. So to enable single sign-on, we must have the credentials for the different forests, and it is satisfied, so we get the green check marks. So one of the concepts in the curriculum is we could configure this Entra Connect server in staging mode, so that if our main Entra Connect server goes down, we will have one to quickly stand up. It's a common point of confusion that you need one Entra Connect server per forest, but you actually just have one Entra Connect server per Entra ID, and all of your forests need connectivity to the Entra Connect server. So the idea is you might have several in staging mode, just in case your main Entra Connect server goes down. But this will be our main Entra Connect server, so we'll start the synchronization process once the configuration completes. And then at this point, we'll wait for the configuration to finish and the sync to occur, and then we'll see the user pools, the user pool start to build here in Entra ID. Then I will time compress this just a bit here. Okay, excellent. Now the configuration has completed. So Entra Connect will replicate, I believe, every 30 minutes. And then we can also force a replication by using the start AD sync cycle policy type delta command. AD sync cycle, and then policy type delta. And then we get this nice message that we have successfully synced our domain controllers to the cloud. So we'll bounce back to our Entra tenant, the Entra admin portal. And now we can see all of our users popping into the Entra ID user pool. So you also notice here, like Airman is airman@moosewire.fun. And then we also have Bombman at minecraftmoose.com. And then here is Drillman at dev.moosewyre.fun. So we have users from 3 different domains being pulled into the same Entra ID tenant. And those are all part of the same forest. And then we also have users from a second forest, the 4th domain, which is megamooselabsfun.com. So in this user pool, we have users from 4 different domains and 2 forests. So we'll take a look at the properties of the users. So we'll take a look at Pharaohman. And we can see that the properties from Active Directory have synced up into the cloud. So he is an Eagle River user, and he is a programmer in the programming department. If we try to edit these properties, they're grayed out because they because the account is being synced with an on-premise Active Directory domain services server. So if this was a cloud-only account, we could absolutely come in here and change these properties. But since this account is synced to the on-premise domain, we can't update this information. Now that everything is synced, we'll take a look at how it looks in the Office admin portal. Let's go to office.com and then to the admin portal. Now we can see all of our users in here. They're all unlicensed. But what we could do is, for example, we'll go into Hardman, come into licenses, and then if we had a pool of 365 licenses, we would be able to check this box, click Save Changes, and then he would have a 365 license. So now I'll demonstrate how to update the information in Active Directory and sync it to Entra ID. So we'll come over here to our privileged access workstation and log in as Megaman, which is the enterprise admin. So we'll find we'll change Iceman. So we will make Iceman, we'll make him the lead Anchorage programmer, and he will be the lead programmer. So we'll click apply. Now to get the information synced to Entra ID, we would have to wait for the next sync period on the Entra Connect server. But we can use that same command that I showed earlier to sync the information from our on-premise Active Directory servers into the cloud. And then we'll also connect to our child domain. And we'll find Ferroman. And we'll also make him a lead. Oops, I put that in the wrong place. So he will be a lead programmer in the programming department. And then we'll give it just a moment to sync. Okay, so I gave that just a bit of extra time. I'll just run the command one more time for good measure. So now we'll check to see if Feralman and Iceman are now lead programmers in their respected sites. So we'll go in here and find Iceman. And we'll see he is now a lead programmer. So if we came in here and we wanted to change it in the Entra ID portal, we wouldn't be able to. We'd have to go into Active Directory and then let it sync. Then we'll also check Feralman. And he is also a lead programmer. So we saw earlier he was just a programmer, and then we updated. Now he's a lead programmer. Okay, so that's pretty neat that we got all of our users from 4 different domains all into our Entra ID tenant. The last thing to do is to demonstrate how the password hashes were synced to the cloud. So we'll go to portal.office.com and we'll sign in with one of our Entra ID accounts. So we'll do Skullman, or we'll do Metalman. Okay, excellent. It finds the account, and the password that it has is the same password as our Active Directory environment. So we'll program in our Active Directory password, and then we're allowed to authenticate. And then it wants me to set up multi-factor. So that's pretty neat that we were able to sync all of that information into our Entra ID tenant, including the password hash. So when I entered my password, it went through the hashing algorithm and then matched the hash that was stored in the cloud. And so I might as well just continue the authentication. And now we have logged into portal.office.com, and if we had a license, we could access the entire Office suite. But right now we're just greeted by Copilot here. But we're signed in as Metalman at moosewire.fun. So I'll bounce back to my cloud admin. And we'll go to Entra. And then we'll take a look at Metalman. And then we'll notice in the authentication methods, we can see that we've set up the Microsoft Authenticator app to our on-premise Active Directory account. So that will conclude the Entra Connect portion of the lab. So the last few pieces, we will join a Linux domain, or excuse me, a Linux server to the domain, and then install an instance of Windows Admin Center and see how it behaves in our lab environment. Now we'll create a Linux virtual machine and join it to the megamooselabsfun.com domain. So here we can see in the lab infrastructure, I've taken the servers we won't be using and put them in the saved state. So AnkPa01, WAC01, Eagle River Server 01 are all in a saved state, and then I've turned off the Entra Connect server. So all of the domain controllers are still up and running, and then one member server that we'll use to do the configuration for this portion of the lab. So the first thing we'll do is create a Linux virtual machine. So on my GitHub repository, I have posted a custom function, this new-lab_VM command, that allows me to create virtual machines using a ISO file. So we're using the Ubuntu ISO. And this machine will have 2 gigabytes of RAM. So when the virtual machine first boots up, we'll have a problem where it won't boot from the ISO, so we'll need to disable secure boot so that we can launch from the ISO file. So I made this bit of code that will stop the VM, disable secure boot, and then start the VM. So this time when we connect in, we get the installation wizard. So we'll be doing Ubuntu server, and it gets its IP address there, and this IP address is from my DHCP server, and this is just for the installation portion. After the operating system is installed, it will pull another IP address, most likely .43, but we'll verify after the installation. So it needs network connectivity for this part of the installation to verify the mirrors. We're going to use the entire disk. We're going to call the server Jun Linux 01. Username admin 01. We won't do Ubuntu Pro, but we do need OpenSSH. So now I will pause the recording here while the operating system installs to time compress the video just a bit. Alright, the installation has completed. Now we will reboot the Linux virtual machine. One thing I have noticed with these virtual machines, these Linux virtual machines, is there's a problem with the installation media during the first reboot. So just make sure you hang out long enough to get back to the login screen. So we'll log in here. Do IPADDR grep ETH. And indeed, the IP address was incremented by 1. So the IP address of this Linux box is 192.168.99.43. Now we'll connect to our management server. As Megaman. Which is the enterprise admin. And then we'll configure the lab from this workstation. So first we'll just make sure we can ping our Linux box. And we get a response from our Linux machine. So now we will enter a PS session to our domain controller for megamooselabsfun.com. Which is John DC01. So now we will create this DNS record of 192.168.99.43 for the Jun-Linux01 server. We add in the DNS record, we see it's been added, and we can also see the DNS records when we joined SVR01 and DCO to the domain, and we can also see Jun DC01's DNS record. So now we'll try to ping Jun Linux 01. And we get a response from our Linux box. So now we'll try to SSH to it. So the way this works, SSH, username, @ and then where you want to go. So we could type in the IP address, but in this case we're using the fully qualified domain name because we have DNS resolution through the host A record that we created. So from the management tools here in DNS, we can also come in here, look in forward lookup zones, look at our DNS records, and here is the DNS record for Jun-Linux01. We could have created the record here, but we did it with PowerShell. So now we will attempt to log in. Username is admin01 to our location. So we need to remove our SSH file. This hangs on to try to make SSH a little bit more secure. So I'm going to remove this file from some previous SSH tests. So now when we connect, we'll accept the fingerprint. Now we are connected to our Linux box through SSH. We can see the IP address. So the neat thing about Windows Server 2025 is our command line session has these neat tabs. So I'll open up another tab and go to the domain controller for megamooselabsfun.com. And we're going to create a file share and share out a file that has this happy character with curly hair and a clown hat. So these commands are just testing being able to access that file. So we can see when we do get content, we can see the contents of the file. Notepad didn't work in that PowerShell session, but we can run Notepad from the management workstation here, and then also see the contents of this file. We can also open up File Explorer and go to the file share location, which is jun-dco1/yahoo or /yahoo. We can see the file share here, the file, and the file contents. So we'll use that file and that folder and this file share for testing with Kerberos tickets. So we're going to start by the sudo apt update and sudo apt upgrade commands. This is a good practice when bringing your Ubuntu servers online for the first time. Sudo stands for superdo, and it's the equivalent of the Windows administrator in Linux. Since I'm in Anchorage, we're going to set the time zone to Anchorage, Alaska. For good measure, we're going to run this ntp command. Since we will be joining this machine to Active Directory, just make sure the clocks are synced and look good. So I've got a long list of some packages here that we'll install. So by default, the Ubuntu server will not just join Active Directory, but developers have created these packages that we can download that then allow us to join the machine to an Active Directory domain. So we don't necessarily need all of those just for that functionality, but I created a good list of packages that you'll need when you start joining Linux machines to an Active Directory domain. Which might make managing them just a bit easier. So some of the main ones are Realm MD, SSSD, and the sama-common-bin. So now that we have those packages installed, we have a few more to install, but we're going to create a configuration file before installing those other packages. So in the Linux world, in Ubuntu, Nano is the equivalent of a text editor like Notepad. So we're going to open Notepad as a superdo user and add administrator user to this file called krb5-conf in the etc folder. And then we will paste our configuration into this configuration file. So the default realm will be megamooselabsfun.com. In the Linux world, a realm is the equivalent of a domain. So we would call it an Active Directory a domain. Our domain is megamooselabsfun.com. In the Linux world, they refer to it as a realm. The KDC is the main server that hands out Kerberos tickets. So it's your Kerberos distribution center, and it will be Jun-DC01. And then we program in the default domain. This is for a separate lab in the future, but it won't hurt the configuration. And then these are to solve the issue that Linux is case sensitive. If this is typed in, it actually means the uppercase version. And then we also have our C paths. So now we will save the configuration. And we can use sudo cat just to make sure that the save definitely happened. So our configuration file is set. So now we'll install a few more packages. This one allows us to get Kerberos tickets. And we needed the configuration file before we ran that, otherwise it would run on its own. And then we're also going to install SMB client, and that is how we will be able to test the Kerberos tickets. So we will get a Kerberos ticket from the megamooselabsfun.com domain and then use SMB to test. So we'll install these packages. So now we're ready to do some testing before we join it to the domain. So now we will test if we can access the C drive from our Linux machine. And we get this error message. So now we're going to get a Kerberos ticket from the megamooselabsfun.com for Mega Man. Now when we do klist, we can see we've been issued a Kerberos ticket from the megamooselabsfun.com domain for Mega Man. Now, when we try to view the contents of the C drive on the domain controller, we are allowed access because Mega Man at megamooselabsfun.com is an enterprise administrator and would have that right to view these files on the C drive. So we can also see our yahoo.txt file. So now we will destroy the Kerberos ticket. We have no Kerberos tickets. And then we'll see we can no longer access the C drive. And then we also cannot access the file share without the Kerberos ticket. So now that we did that little demonstration on Kerberos tickets, that was before we even domain joined the machine. We will now domain join the Linux machine. So we'll go into Tools, Active Directory, Users and Computers. We're connected to the WAC domain. And we're going to see the Linux box show up in Active Directory. So we'll come over to our Linux box that we are SSH'd into. Run the command. And now the machine is part of the WAC domain. So we'll come over here, hit refresh. There's our Linux, our Active Directory object that is a Linux machine. So recognizes it as a Linux box. So now that we've joined the machine to the domain, we can do some testing. So we're going to SSH to the virtual machine using an account that is in the WAC domain. So the only account on the Linux box is a local account, an admin account. And we're going to use a domain account to log into the domain join Linux virtual machine. So I'll exit this session. And the syntax is a little tricky. This first part is pretty straightforward. This is the DNS record that we created earlier. So this just represents the IP address of the Linux box. And if you remember, I said it goes username at where we want to go. The username is this bit, instead of admin01, we use the entire Megaman at megamooselabsfun.com at johnlinux01.megamooselabsfun.com. So the tricky part is the two at symbols. Oops. And we'll go ahead and type in our password. And now we are remoted into our Linux box as Megaman, which is an enterprise administrator. But if we try to do sudo su, which gives us super user rights, we are not given super user rights by default. So even though we're an enterprise admin on the Linux machine, we are not any kind of administrator. But pretty cool that we can SSH into the device. There's a few tests we can run. So I have my Kerberos ticket here because I am Megaman. And so now I'll be allowed to check the contents of the C drive on the domain controller. We could destroy the ticket, and then we'll get errors. But since we were logged in, we were issued the ticket. In fact, we'll just log back in real quick. we see we're issued a new ticket on a new login session. Now we're going to create a standard user. His name's going to be Beat, and he's not going to be a part of any special groups. So we'll get connected to our domain controller. And we'll create this user. His name is Beat, which is Mega Man's bird. Then we're going to create a new group. We're going to make it a domain local group. We're going to call it Linux sudo admins, and then we're going to add Beat to that group. And then we'll take a look at the members that Beat is a part of. And the only group that he's in is Linux sudo admins. He's not an enterprise admin of any kind. So the next part of the script, the goal is to give a user in Active Directory super user administrator rights on the Linux machine. That was from an earlier version of the script, so in this demonstration we'll just add the users with the graphical user interface, and then I'll update the code on Git. But for now we'll just add the users with the graphical user interface. So we'll bounce over to the graphical user interface on our management workstation. We'll hit refresh. We can see we have this user Beat. And he is a member of the Linux sudo admins group, which is right here. So we need to SSH back into the virtual Linux box with a machine with an account that has sudo privileges. So that's admin01. So we'll connect into the Linux box. And we're going to create a file called the superdoers.d ad-linux-admin-sd-linux-admins. So we're going to create this file using the nano text editor. And now we're in the text editor. And so this bit of code will allow our users from the Linux-sudo admins group at megamooselabsfun.com to have super do privileges on the Linux machine. So they'll have administrative rights on the machine. So we'll paste this bit of code in here. Then we'll just confirm it was saved. And there is the configuration. So now we'll SSH to the machine and test if we have superdo rights. So let me get out of this session. We'll SSH the machine using our Beat account. to the Linux box. Now, if we do sudo su, we are allowed to be the root account. So we've just taken a standard user from Active Directory who has no rights at all, put him in a group, and then now he has he has sudo rights, administrative rights on the Linux machine. So we can see the sysvol folder, but we cannot see the C drive because Beat does not have that right. He is not in any kind of group that allows him to look at the C drive of the domain controller remotely. But he will be allowed to look at the file share because of the way that the permissions are configured. My Kerberos ticket is accepted, and we see the Yahoo txt file. And here is our Kerberos ticket for Beat. So that Kerberos ticket was issued from our Active Directory domain controller to our Linux machine. And one more demonstration. We can use the kinit and now we get the Mega Man Kerberos ticket, and then even though we're Beat, now we can look at the C drive. And that's just because we got the domain controller to issue us the Kerberos ticket. And so this will conclude how to join the Linux machine to the megamooselabsfun.com domain, and then just different ways you can start testing. The final part of the lab will stand up an instance of Windows Admin Center on Server Core, and then we'll add some machines to Windows Admin Center so we can see how it behaves. I'm also going to turn off the Linux box and reassign it 1 gigabyte of memory. So we'll connect in to our instance of Windows Admin Center. Or excuse me, we'll connect into our server that we'll configure to be our instance of Windows Admin Center. So we'll log in with our enterprise admin. So we have already added the computer to the domain. So the URL as of May 2026 is aka.ms/WAC download. So we define that in the string variable, and then we will define an install variable, and then we will download the file from the URL using the installer object as the file path. So we'll install it to the C directory. Then there's some checks if there's a problem with the download, if it's not there or too small. And then we'll install Windows Admin Center. So I'm just going to grab this bit of code. And we will install Windows Admin Center on Windows Server 2025 Server Core. So even though this is Windows Server Core, we will get a graphical user interface for the installation wizard. I'm sorry, that's probably a loud thump. So we will prompt through the wizard. We'll do the custom settings just to look at them. We're going to use the fully qualified domain name. HTML form login. We'll use port 443, but we will generate a self-signed certificate that expires in 60 days. This will be the fully qualified domain name we'll use to access Windows Admin Center. And for the lab environment, we'll allow access to any computer. We'll do HTTP for the default communication mechanism. This is about WinRM communicating over different protocols. Install updates automatically, diagnostic data only, and now we'll install our instance of Windows Admin Center. After the installation, if you don't reboot the server, we need to just triple check that the services are running and then start them if they are not. Okay, the installation has finished, and we're going to start the Windows Admin Center. First, we're going to see if the services are running and start them if they're not. So we can see this service is not running. If we rebooted the server, it would be. So now we're starting it manually. That way we don't have to reboot. And then we'll set the startup type to automatic for the Windows Admin Center service. So that completes the configuration. So now we'll test it. So we'll connect to Jun SVR01. So this is the management workstation in the other forest. Now we're going to navigate to HTTPS whack01 minecraftmoose.com. Did one too many T's. So we'll click Advanced, continue to the site anyway. Now we're at the login screen for Windows Admin Center. So it's running on Server Core, and we're on our management workstation connecting to it. It is domain joined, so we use Minecraft Moose Mega Man. Now we have successfully signed into our instance of Windows Admin Center. So we'll connect in to kind of get the default extensions going. And this is just a quick look at what we get by default. We can look at the certificates. The curriculum pushes this as a big plus, that it's much easier to look at our different certificates in Windows Admin Center. We can also take a look at the files on the C drive, and also firewall settings and installed apps. So my default image has, my golden image has Python, so all of the servers have Python installed on them. So now we're going to start adding servers to our Windows Admin Center. So you can add cloud machines. There's all kinds of different ways that you can add servers into Windows Admin Center. This demonstration is just focused on getting our Hyper-V lab environment behind a single pane of glass in Windows Admin Center to manage. So we'll begin by adding some of the domain joined servers. So we'll get the domain controller first. And actually we'll do search Active Directory. It finds it. And now it's been added. So next we'll add in the other domain controllers. And we'll do them directly by IP address. I guess first we'll try name resolution. So GNOME DC01. See if I can find it. And it finds it. So we'll add it. Then we'll look for the Eagle River domain controller. And it finds it. So we add it. Then we'll add the Juno domain controller. So since we're in a different forest, it wants a different set of credentials. So we will use Mega Man. megamooselabsfun.com. And now it's been added. So we'll go ahead and connect to the Juno domain controller. And we can see that we're getting all the information about the server. See 1 GB of RAM, its domain, and computer name, operating system type, free space. So the Windows Admin Center is being developed all of the time. So inside of settings in the cog up here in the upper right, we can go to extensions, and there's a bunch of other extensions that aren't loaded by default. So the one we're interested in is the Active Directory extension. So we're going to get that install going. And we'll also do DNS. And it will take a moment for these to be installed. Now we've got Active Directory and DNS installed. So we'll go back to our Juno domain controller. It's going to want us to authenticate again. Didn't see the extension yet, so I believe we're still waiting for the extension to get installed. So let's try GNOME first. So we're going to go ahead and open up a new private window now that we've installed the extensions. So HTTPS ANK WAC01. Now we're back on the server. So we'll go into the GNOME domain controller and see if those extensions have loaded yet. Let's go back to extensions. So it may just be taking a moment for the extensions to be installed. And now we see that we've got the Active Directory extension installed. So it just took a moment for everything to sync and get installed there. So now we have DNS and Active Directory. So we're on GNOME DC01 right now. So we'll just take a look at what we can see. And then we can take a look at the computers group, the domain controllers. We can see there's our GNOME domain controller. Here are our Mega Man 2 users. So if we wanted, we could create a new user from the Windows Admin Center using the Active Directory extension. And we'll also take a look at DNS. And this may take a moment to install this tool. So we will come back after we get the notification that it's installed RSAT. So we'll leave this window going and we'll open up a new tab. And we'll add Jun SVR01. Excellent, and now we are connected to the Jun server. We can take a look at the server information. Since I switched sessions, I lost my authentication there, but that's okay. So we'll just go back to the home page. We can see we've connected into all of our servers. And it must take a moment for the extension to pop in for Active Directory. There it pops in. And then here are our users. So Drillman is an Eagle River programmer. So that will conclude the portion of the lab looking at Windows Admin Center. And then we'll also kind of take a look at traditional server manager real quick here to wrap everything up. So I'm going to save this virtual machine and start the privileged access workstation in the minecraftmoose.com domain. And we're just going to add some servers to server manager and take a look at how they behave. So we will right click on all servers, add server, and we'll just add the domain controller. When the devices are domain joined, they're very easy to add to Windows Admin Center. So ANCDC01 being the main example there. And then we'll go ahead and add our WAC server. So we did set our trusted sites on the privileged access workstation to any IP address. So for the trusted clients, we trusted any IP address. and that is needed when we start adding servers and other subnets, even if they are part of the domain. So our PA is in a different domain. Even though it's domain joined, it's in a different subnet, it's a different local area network. So we needed to set the trusted hosts to specific IP addresses, or in this case, I just chose every IP address. So now that the servers are loaded into Server Manager, we can use different tools on them. A good example is just Disk Manager, file and storage services, and we can look at all the disks of the different servers that I just added to Server Manager. And we can also look at shares, so we can see the wallpaper share on the domain controller. So now we're going to add a server. We're going to try to add the domain, the WAC domain controller. So we're going to do it by domain, the IP address, or FQN, the fully qualified domain name. So we'll do GNOME. So it finds it, and we add it to Server Manager. So then we can right click on it on these devices and see the different options that we get. And now we can see GNOME's disk. So that's our tree domain, the domain controller for the tree domain, and its disk. Then we'll add the Eagle River domain controller. Finds it. And then we'll take a look at the different services. So here we'll look at DNS. Here are the file and storage services, disks. And now we can see the Eagle River disk. So we'll do one more. We will do John. Finds it. So this one is slightly different because he is in a different forest, so he will be trickier to add to the server. We get this access is denied. So I believe what we would need to do on the Juno domain controller, we would set the trusted hosts, maybe do some firewall stuff, and then we would be able to access it through Server Manager. So this is a great way to manage servers through a single pane of glass, but there are limitations. So you can see right here, by default, we would have to do some extra configuration to access the domain controller in the megamooselabsfun.com domain. But the management can be done with Windows Admin Center. So the idea is Server Manager is old school, and then Windows Admin Center is the new way to manage servers. So we'll hit our WAC server here. So WAC 1. Oops, I typed that in wrong. Inc. WAC 01. Ooh, I have a bad type in there. Minecraft.com. So now we click Advanced, continue to the Windows Admin Center. So we did access the Windows Admin Center from the Juno member server, and now we're back on our privileged access workstation, and we can see all of our servers that have been added to Server Manager. And this will conclude the portion on Windows Server Manager and Windows Admin Center. And this will conclude the Active Directory Domain Services Entra Connect lab. So thank you for watching. And thanks for sticking to the end with me. So that was a lot of information. So thank you very much for watching.
Initializing ADDS and Entra Connect lab. Configuring domain trust plan. Trust relationships established between root, tree, and child domains.
Scaling the lab to global proportions. Every site now running Active Directory domain services. Thank you for watching, Vince.